one and all. Good morning. The subject name is compiler design. Now, in this lecture, we are going to give a brief overview of what is the addresses in the target code. That is the usage of different addresses in the target program that is to be generated with the help of a compiler, and how these addresses are generated, what is the allocation process, this activities will take. Now here we know that the compilation, the runtime environment, this is called as runtime storage management. And that means at compile time we know that some of the process activities to be taken place, and at the runtime another activities have to be taken place. So at runtime we will see that runtime, what is the information that is to be needed at the execution of the procedure. What is the information that is to be required at the time of execution of the procedure in a block of storage which is called as activation record. Here this activation record which include the storage of the names like local and procedure, local to this procedure. So one is static allocation, another one is stack allocation. The activation record which contains the procedure, that is the name of the procedure, followed by a list. This list which is local. This parameter is list which is local, and for that particular procedure, local to this procedure only. That means we are going to use this suppose A comma B. So these two A, B are local to this A, B or local to this procedure. Local to this procedure. And the strategies here we applied, that is static and stack allocation. So in static allocation, the position of activation record in the memory is fixed at compile time. Previously we have seen in some previous lecture we have given the procedure and parameters of an activation record. See this, whenever the procedure starts, control comes to this procedure, the activation of the procedure takes place, then a record is to be created. You know that a record is to be created. This record is called as activation record. This record is called as activation record. When it will be record is to be created, the control comes to the beginning of the procedure, then start of this automatically the variables and names which are allocated in this inside the processing things that can be processed through the form of this activation record. And this memory which is fixed at compile time. Whereas in the case of stack allocation, the previous one is static allocation. In stack allocation, a new activation record is pushed onto the stack for each execution of the procedure. In stack allocation, what happens? Stack, we know that a stack is a box-like structure where the elements are to be pushed onto the one side, and we are going to remove the elements from some other side. That is pop of this pop. That means pop means removal. Here, whenever the activation record is created, then that record is to be pushed. Pushing means inserting. Where it is inserting? It is inserted into the stack. That insertion name is called as push operation. So there are two operations that is to be performed by the stack. One is a push operation, another one is a stack pop operation. So every time you are going to create a record, a new activation record, and pushed onto the stack, and then after completion of the procedure, the activation record ends, then it is to be popped out from the stack. So like that, the execution of the procedure takes place. So this is called as the stack allocation process. Static allocation, only the activation record, that is here the position of activation record is to be available inside the memory, and it is kept constant at compile time. Whereas the stack allocation, a new record is to be created, that is activation record, and it is to be processed. That means any variable names, all these to be noted down, the parameters, that uh, list of all the routine activities which are to be done inside this activation record is to be processed clearly. That is whenever it is pushed onto the stack. And then the completion of the procedure that is statements are to be completed, then end of the record takes place. That means end of the procedure. End of the procedure means activation ends. That is to be processed. And while the three address statements which are associated at the runtime. So while run, we know that static and stack allocation at runtime, some of the allocation and deallocation of the activation records. Now, what are the three address statements that can be used for the purpose of this allocation and deallocation of records? So we are going to use a call name. Another one is returning. Suppose if the function is procedure is called, procedure is to be called procedure name. So whenever activation begins, then we are going to implement a call. Control comes to this place, we are going to implement a procedure that is called. So the activation record creating and allocation of the objects can be done at runtime. So these three address statements associated at this one is call, and the return type, and halt. Halt means stopping, and action performing the statements, and placeholder for the other statements. Here we are going to assume that runtime memory is also divided into some areas such as code and static data and stack. We know that this code is to be delivered before implementing this activation records, and objects to be invocation, and inside a stack data, that is static data, also to be monitored. First, static allocation. In static allocation, a call statement in the intermediate code is implemented as a sequence of two target machine instructions. So, as a two target machine instructions. Previously, we know that a call statement is to be return statement, halt, and action. These are the runtime allocation. In this allocation process, first a call statement is to be implemented with the help of these two target machine instructions. What are the machine instructions that is to be used? One is move, another one is go to. So this move instruction is going to save the return address. Each and every time a return function is to be executed with return some information. So that return address is to be cached out by using this move. And a go to is the one which is used for the purpose of transferring the control to the target code to the called procedure where it is to be called. So there is a procedure which is invoked already. That means called procedure and callee procedure. So whenever it is invocation happens, then immediately transfer the control to the called procedure. So here in move, we are going to use here the return address with the help of this hash here. Hash here means the code that is to be available plus 20. So this is the where the callee, that is static area, static underscore area, where this address is to be available. And then by using this statement go to callee dot code underscore area, we are going to invoke this that is transferring the control to another procedure, that is another called procedure. So here the what is the address of the activation record that is to be available with the callee dot static underscore area, and callee dot code underscore area, which is the first instruction for the called procedure. Which is the first instruction of the called procedure. So in the inside the procedure we are having a several list of statements. So out of that, the first statement instruction that is to be available. and here this return address to be available. It is the address of the instruction where the following the go to address instruction, where the return address is to be available. So that address is to be returned. The return address is to be available with that Kali, that is here plus 20 Kali underscore dot static underscore area. This is the address of the instruction following the go to instruction. And the second one is return. So here call statement, return, halt. Whereas the second one is implementation of return statement. So this return procedure, return from the procedure, that is Kali procedure, implemented by a statement that is called as goto. Here goto means go to Kali dot static underscore area, which is used for the purpose of transferring the control to the address saved at the beginning of the activation record. That means previously you have taken one block of statements, and each time the control is transferred. Whenever the condition is satisfied, if condition is true, then go to something. So we are going to implement the an edge transition. In the previous lecture also discussed about this scenario where the last step of the instruction condition satisfied with an edge form, then it reaches to the first statement of the beginning of the statement. And that means here the control is transferred to the address where saved at the, this is the beginning of the instruction and it is the end of the instruction. These out of this begin and there will be several instructions are there. So the last statement is get connected to the first statement of the instruction, so that by applying this procedure, that means a return address, that is a statement which is completing with the 3 or 5 statements, that return form address can be given implemented with this form. And another one is action statement. This action is used to implement action statement. So action is the part where the control to be scenario taking place, each of the statements one by one. So that all the statements we can put in this one and to implement the corresponding actions. Halt is the final step of this instruction format, and this returns the control to the operating system. That means we are saying we can say it is the exit or end of the particular program, and we are coming out of this total control, each and every statement taking place, and finally reach the end by end the last statement of the instruction, and it comes out of that program so total code. Then we can say it is a halt, completed exit. In stack allocation, every address is to be recorded with the help of this storage information inside the activation record. So each and every time activation record is to be maintained with the help of all the relative names, addresses, and registers which are available. So that activation record can be accessed via offset values from the values which is already stored inside the registers. So maybe we are going to use an instruction format move register R1 comma R2, and another instruction say add or add C comma R1. So like that the values of the registers hold a different set of address. That means while using this move instruction, R1 register contains some allocation values, R2 contains some allocations, and all these can be required at the implementation of storage of this record information inside the activation record. And this position of the record where it is available in the registers and the words which are available can be accessed by using the offset mechanism with the help of these register values. And the code which is available for first procedure initialize stack by SP. SP here it is called as stack pointer. So that is to be maintained at the beginning of the start of the stack. Every time we are going to initialize the stack pointer. So that's why move this by specifying the instruction move hash stack start sp. That means initialize the stack pointer at particular place, and we are going to write the code for that particular procedure, and then halt. Halt is indicating that termination of execution. That means program completes. It comes out of the programmatic statements. And the first statement is to be written as initialize the stack coordinate. So that means it start of stack area where the in the memory where the start of stack area to be released or start the implemented with the help of the stack pointer only. So this initialization of stack, first point to note down, that is move with the stack pointer with where SP, and initialize the code for the procedure, first procedure, and finally terminates the operation. So these are the three steps. That is move. What is the stack pointer that is to be available? Second pointer is the code where to be written. That is the code for the procedure where the code is to be available, and third step is halt. So call statements are to be implemented with the help of this notation such as add, that is caller record size. What is the record size? And then for comma sp stack pointer. So we are going to increment the stack pointer and then return the save address. For that go to call it c and then od underscore area where the record size, that means size of the activation record, is to be mentioned, and also address of the instruction which is following the go to statement. These are to be which are to be available for the implementation of call statement. And return statement which is written with this go to instruction *0. Initially stack pointer is to be assigned with some value, and later we can implement with the remaining steps. Caller record size, that means here we are going to reduce the counter value with this stack pointer, and then you can set with the reset with value restoring the previous value. Initially it is 0, and after that you perform some operations with that one, and then finally after completion of this activity we are going to set to the default value. Then you can decrement the stack pointer, and after applying you are going to retry the previous values. Another important one is how the runtime addresses for the names. Generally we are going to give the names for this activation of the records and procedures. Runtime, generally this runtime, some of the addresses may be vary from one point to another point, where because the memory allocation is different to with the variables registers and some of the words in the memory. So this strategy which is applied for the storage allocation and the names which are available local data in the activation record for a procedure, which is used to determine the storage for the names and then the accessing of the names. Storage for the names which is accessed depend on the procedure which is activation at the time of control begins. And the name in the 3 address statement, it is a pointer which is assigned to some symbol and the table entry for the name. While making this entry names inside that record with the list of values, then the 3 address statement, what is the name that is available in the 3 address statement? It is a pointer to the symbol table entry for the name. That means here we are going to write a activation record with some list, that is where the procedure is to be available with the name. So it's name 1, name 2, like this, and this having this name with having some entries with the symbol table information. The symbol table is to be written with the corresponding IDs followed by the values, serial number, and ID names with the value. So here name 1 corresponding value 160, name 2 corresponding value 200. So this whenever a name in the 3 address statement is to be identified, then it gives a pointer to the symbol table entry. So this name 1, this is the pointer to an entry of the symbol table. This is a symbol table structure. In this we are going to figure out all the list of here there is a method we are going to use, a lookup method. The previous lecture also we have discussed how the entries are to be entered into the symbol table. Here we are going to first look up name 1. So name 1 entry, that means whether it will search for the first entry, second, like this, keep on searching all the names. And if the name 1 not equal to any other name which is already available, that means it doesn't contain any name, then it will store with a separate name 1 entry with the corresponding value. Suppose if name 1 is already exist, then that value is replaced with the corresponding. So that's why there is a pointer which is assigned to these entries of the corresponding symbol table, so that whenever the name appears in the corresponding 3 address statement, it will retrieve the data which is linked to that one. So it is the data, that means this allocation strategy data is a local data which is available in the activation record, and then we are going to determine the procedure and for the corresponding storage name. Here storage of names takes place for each of the values in each of the names in the record, activation record, and these are to be reflected as pointers to the symbol table entries. So whenever a name is to be wants to resolve, then by using this axing of the pointer names, that values are to be retrieved. So here 200 will be retrieved with this symbol table entry. Here 160 will be retrieved into the symbol table entry. So by applying this lookup method, we are going to verify whether that entry is available in the symbol table or not. So sometimes multiple entries, so it did not occur. So there is a code that is to be written. Previously we discussed about this topic, and like that we are going to return the addresses corresponding names. So what is the address that is to be already generated in the symbol table? So that address is to be retrieved back with the corresponding names, so that that name is to be resolved in the mentioned in the 3 address statement, and this is to be carry out the activation record, and that activation record sent to the procedure which is to be currently running, and that procedure is to be gives the correct values after completion of this one. And another one is a dynamic allocation. So that means here the execution of the program at runtime, that some of the things that is to be varied from compile time to the runtime. So at runtime, allocations of the things, some of them is to be varied. So dynamic, it is called as a dynamic storage allocation strategy. That means the requirements are different from one to another. Whenever the programs, some of the data which is not really known at compile time, then that type of the compile time, what are the things that is to be changed, that is not known clearly sometime. Then at runtime you can predict that data. That means 2 criteria were given in the previous section as necessary for static storage allocation, which do not apply for a dynamic storage allocation schemes. Each and every time the size and number of each and object need not be known at the compile time, but at runtime it must be detected what is the size of that one, what object name which we are using, that is to be mentioned clearly at that as a allocation process at a runtime. Whenever the block is to control comes the execution to the particular block of statements, or entrance into the procedure activation. So these while activation records itself, previously we have seen the addresses, names, resolving pointers linked to the symbol table. All these things are to be activated and recording down with the return address statement, so that once again the 3 address statement note down the corresponding address values. Sometimes more than one occurrence of data also may exist, That's what I am saying. There is a methods which are available in the symbol table entries. We are going to look up that with the names matching, even the same name but different value also may appear at sometimes. So that new occurrence initiated at runtime whenever a block is to be entered. So there will be several blocks are to be executed simultaneously one after the other. So each time a block is to be control comes to that execution of the block statements are to be executed, a record is to be activated, and that a new occurrence of the corresponding data is to be noted down. That is the initiation process for each of the data object, for first initially. And this runtime environment manages runtime memory requirements with the following entities. One is code, procedures, and another one is variables. Here code is known as the text part of the program, does not change the runtime. What is the things that is? Only the changes memory requirements that is to be happen at the compile time only. Whereas a procedure, this is the static, but they are called in the random error. So stack storage is used here. Stack storage is used to manage procedure calls and activations. So where the static data items which are to be available, and some of the variables which are used at runtime only, and these are makes, that is global variables, or sometimes we can call it as constant variables. And this uses the memory allocation, that is heap is also one of the memory allocation scheme process, which is mainly used for the purpose of allocation and deallocation of memory for the variables at runtime. Allocation and deallocation of memory for the variables at runtime. Heap allocation. Here, heap allocation, that means some of the variables which are local to a procedure. Here, allocations and deallocation. Allocations means allotment of the things, and deallocation means removal of these entities from that at runtime. It is used dynamically allocation of the memory to variables and claim it back when the variables are not required. So if the variable exists, then that is to be used for the purpose, and then that is exist. And then if not used by the sometime and not used, and they are will be removed from the allocation. Then not used, removed from the allocation. That is a deallocation process. As part of the language implementation, several programming language uses several notation for allocation and deallocation. That is, as a part of C++, we are going to use a new operator for allocation of things, and delete, which is used as a deallocation process. That means whenever an memory is needed for that particular objects at runtime, then a new operator can be used, and a deallocation occurs. A delete operator is to be delete is to be used for the purpose. That is as a part of C++ programming notations, and different Java we can use unused objects, garbage collections. Like that, several programming implementations are there having their own approaches. And here, the allocation of memory, both stack and heap memory, both the sides are available as they are grow and shrink as per the requirements of the program. If it is needed, then the both ends are to be used to be modified as per the requirement. So if array size is to be determined, suppose A of 10, A of 10 and 5 entities only used and 5 not used. So, or if you determined this used only and not used, then as per the requirement used, then only the fixed amount, the amount of memory which is dynamically, it can grows automatically 5. Suppose in the program, if the requirement is 7 or 8, then it automatically extends the string dynamically growing from 5 to 8. 5 to 8 automatically. So remaining two is not used, and this is to be not kept as a reserved purpose. This one, if it is used, then it automatically grows, and if not used, it won't reserve that purpose of the memory. So such type of dynamic usage of this memory area also required. That is the possibility only when the case that is stack and heap memory allocation. So sometimes a fixed amount of memory in the system is required, then this is not available with this case, then where that is this is not comes under dynamic memory, where it can have different set of objects. For example, in this diagram, if you see a text memory, static data, stack memory, and heap memory. So the stack memory is to be extended towards this side, and the heap memory which is extended this side, and this type of thing, it is a dynamic. It is a dynamic one. That means previously you have done A of 100. So if at all if you used only 50 objects, 50 entities, so used only 50 entities, 50 entities not used. Then as per the requirement, it grows stack side heap memory. So the text part of the code, that is allocated as a fixed stack. It is this code is fixed, and heap memory arranged. Static data is nothing but it is a fixed amount of data which is fixed, whereas memory which is available at runtime, that means needed or not needed depends on the requirements. Then it automatically shrinking and going against each other. That means as per stack requirement, activation records as per created procedure activations. Procedure activations are created as per the requirements. How many number of procedure or blocks? Say 5 blocks are created, and as per the requirement, the number of variables and symbol table resolving the references are to be released and then inserted into the stack. Like this side, this will go, and heap allocations this side, the corresponding data which is reserved for the memory, the data items that is to be released for this one, and that is activation. So both ends are to be simultaneously growing as the further data requirement. If not required, that is to be automatically shrinked, reduced to the reduced to the required amount of objects which are really required in that program. So like this, we are going to use this growing and shrinking in case of heap allocation mechanism. That means it is used dynamically. It is used to dynamically allocate the memory to the variables. Dynamic allocation of memory to the variables, and when it is not required, then it releases. And it not required, it is just whenever it once again regain, it comes back, then it gives the regain the control of that variable. That is also possible in case of heap allocation. So a procedure is to be called, activated, and the corresponding local variables, objects, and that memory things are to be assigned. And then after completion of the procedure ends, then there will be no more data which is available in that one. Suppose if the same procedure once again comes back with the same data, then that regaining of the control and then assignments resolving the issues, that type of allocations are there in that entities. As a symbol table, as a part of symbol table entities, these allocations takes place. So this is to be available as a part of this say stack memory and heap memory. So previously you have seen with this two cases. One is static stack allocations, runtime addresses for names, and we are going to use a 3-step notation, that is this one. The 3 address statements, how the result of the runtime allocation with the call statement as well as return statement, halt, and action. So here the call procedure is to be used as the process of 2 address instructions. One is move and another one is go to state. And the return statement is to be implemented with the procedure that is go to Kali underscore the dot static underscore area, and the action statement is to be written as instruction followed by action, which is used for the implementation of action statement. Halt statement simply for the purpose of halting the program. So we have seen this static allocation, heap allocation, and the resolve of the addresses of the issues, and what are the statements which are used in the call statements, instructions that are used in the call statement, and some of the instructions go to instruction. In the call statement, we use go to Kali, and then where the record size is to be implemented, that means size of the each activation record, and the control goes to the corresponding go to statement, and that is Kali. Kali statement means where the procedure once again executed with the remaining statements. This control goes back to the first statement of the instructions that is available. Whereas in the return statement, the procedures are to be written with the instruction format, go to, and then followed by stack pointer. That means initially stack pointer is assigned with some statement that is set with some default value. Then after knowing that different execution of the procedures, statements of instruction, then the automatically the reduction, that is decrement each time instruction format with this one, and then you can restore to the previous value, control goes to this one. And the resolving of the names at runtime, several addresses may be available, and the storage of these names inside this, how the accession takes place, while control activation record is to be created at the initial time, what are the objects that is to be allocated. So those are to be noted down during the execution. So it is a called as dynamic storage allocation, and some of the objects which are to be not known at compile time, that is to be compulsory to be available in the runtime, and where this static storage allocations which are not really applied can be used for the purpose here in the dynamic allocation storage section. And here we are going to know that the size and number of each of the record, and we are going to verify this one with the help of symbol tables, activation record informations, and what is the procedure that is to be called, what is the objects, how many times the occurrence that object is to be available with the values, and all these initiations can be run at the runtime. So these details are to be kept as a part of this code, procedures, and variables. So runtime environment manages runtime memory requirements with the following entities. One is the code, that means what are the statements for the form of instructions to be run. Some of them is not changed at runtime also. So what are the statements which are used these data objects, definitely they need a memory requirement, and that is to be known at the compile time, and that reserves some amount of memory, and that is to be used or not used can be decided at a runtime based on this one. And the second one is procedures. Whenever activation of the procedures takes place, they are to be called each one separately, and whenever the called procedure activates, automatically some of the contents which are stored, that is to be used called as stack storage to manage the procedure calls and activation. Each time a new activation procedure is called, a new activation record is to be created. Automatically, new activation record maintains a list of data objects corresponding names, and these names are to be allocated with the corresponding the values in the symbol table. By using this waxing of pointers, the names to that values, we are going to retrieve the values. So these variables are to be known at a runtime. Unless we are going to represent some of the things as global variables, and this mechanism is called as heap mechanism, and the allocations, deallocations, how the size of the data object can be grown or reduced depends on the context of the program as per the requirement. So that's why it is very important. We are going to use a heap mechanism structure. Why? Because it doesn't use as much requirement of the storage space, only as per the need of the as per the part of the program needs, accustomed to the customer coding needs only. With this type of data objects which are assigned, and some of them are which is not required, they are static, they are kept as a fixed one. They don't move, and those type of data objects we move at the beginning, that is text memory and static data, where this not known size of the data objects which are not known at that time, we are not able to decide. So those things are to be decided at the runtime, that is called as a dynamic part of the program, where it can shrink and reduce both sides. So that is the concept of this data objects which are used in this optimization process. All the contents which are discussed in this one, which are available in this book, that is Compilers, Techniques, Alphas, Development. Thank you. We will come across a new topic, a discussion with the next session from the next session. Thank you very much. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.